Did you know that today's younger generations are aging more rapidly than their predecessors? That's right. A recent study discovered that individuals born in or after the year 1965 are 17% more likely to experience accelerated aging compared to seniors born between 1950 and 1954. This is not just a fascinating scientific revelation, but it's a significant finding with potential health implications that could affect millions worldwide. The study, which involved analyzing blood data for nearly 149,000 people, used a set of 9 biomarkers found in blood samples to calculate each person's biological age. The biological age is what a person appears to be based on the condition of their body, which was then compared to the person's actual age based on their birth date. What makes this study even more intriguing is the potential link between this accelerated aging and the occurrence of certain cancers, especially among adults younger than 55. These cancers, also known as early-onset cancers, are becoming increasingly common among younger adults in the United States and globally. So the big question is, why are younger generations aging faster? The answer, unfortunately, is not yet clear. The team of researchers behind this study are now working to uncover why younger adults are aging at a faster pace and why this is increasing their cancer risk. But one thing is clear: understanding the factors driving this increase in accelerated aging will be key in improving the prevention or early detection of cancers in younger and future generations. This could potentially open up a new avenue for cancer prevention and screening efforts tailored to younger individuals showing signs of accelerated aging. So what does this accelerated aging mean for our health? Well, the implications are vast and potentially life-changing, but don't worry, we'll delve into that in the next segment. Stay tuned as we explore the link between accelerated aging and cancer, unpack the study, discuss the findings, and explore the implications and future research in the following scenes. It turns out, this accelerated aging could be leading to an increased risk of cancer. Let's unpack this a bit. Accelerated aging isn't just about wrinkles and gray hair earlier in life. It's about the biological age of the body, which can be different from the chronological age, the one we celebrate each year with cake and candles. Now, this biological age is calculated using a set of 9 biomarkers found in blood, giving us an idea of what age a person appears to be based on the condition of their body, and it appears that those born in or after 1965 are experiencing a faster biological aging process compared to their older counterparts. The real kicker here is that this faster aging is associated with a higher risk of early-onset cancers among adults younger than 55. We're talking about cancers that are typically associated with older adults, showing up in younger individuals. This includes lung cancer, gastrointestinal cancer, and uterine cancer. And it's not just a small increase in risk. For each single unit increase in accelerated aging, the risk of early-onset lung cancer increases by 42%, gastrointestinal cancer by 22%, and uterine cancer by 36%. What's more, this trend isn't confined to the United States. It's a global phenomenon. Cancer types that were once more common in older adults are now becoming increasingly common among younger adults around the world. It's a sobering thought, right? But it's one that's driving researchers to understand the factors behind this increase. Their goal? To improve prevention, enhance early detection, and tailor screening efforts to younger individuals showing signs of accelerated aging. But how did researchers come to these conclusions? Let's look at the science behind these findings. To unravel this mystery, researchers analyzed blood data from nearly 149,000 people. Now that's a lot of blood samples. But why blood, you might wonder? Well, our blood holds a wealth of information about our health, and it's where we find something called biomarkers. So what is a biomarker? Think of them as little clues or signposts in our bodies. They're biological molecules found in blood, other body fluids or tissues that can indicate normal or abnormal processes, or conditions or diseases. They're like the body's way of sending signals about what's happening inside. In this study, researchers were particularly interested in a set of 9 specific biomarkers. These were no ordinary biomarkers, though. These were the ones that could help calculate each person's biological age. Now, biological age is a bit different than the number of candles you blow out on your birthday cake each year. It's what age a person appears to be based on the condition of their body, and it can be influenced by a range of factors, including lifestyle choices, environment, and yes, even genetics. To get to this, the researchers contrasted the biological age they calculated using these biomarkers with the actual age of each participant, based on their birth date. They also took into account any cancers that had occurred among these individuals. This approach provided a unique way to understand the relationship between accelerated aging and the risk of early-onset cancers. This process might sound complex, but it's essentially like putting together a jigsaw puzzle. Each biomarker is a piece of the puzzle, giving a little more insight into the overall picture of an individual's health. And as the researchers pieced together these clues, they began to see patterns that could help explain why today's young adults are aging faster, and how that might be linked to an increased risk of certain types of cancer. Now that we understand how the study was conducted, let's look at what the researchers found. For each single unit increase in accelerated aging, researchers found an increased risk of various types of early-onset cancers. This statement sets the stage for the stark findings of the study we've been discussing. The results reveal a concerning correlation between accelerated aging and the onset of certain cancers at an earlier age. Let's delve deeper into these findings. For early-onset lung cancer, the research showed a significant 42% increase in risk with each single unit increase in accelerated aging. That's a substantial jump, and it's not the only one. The study also discovered a 22% increase for early-onset gastrointestinal cancer. This category includes a wide range of cancers affecting the stomach, liver, gallbladder, pancreas, colon, and rectum. But the risks don't stop there. A 36% increase was found for early-onset uterine cancer. This type of cancer, also known as endometrial cancer, is typically seen in women in their 50s and 60s. However, with accelerated aging, the risk of encountering this cancer at a younger age drastically increases. The study's findings also extended to older adults, revealing that accelerated aging was associated with increased risks of late-onset cancers. A 16% increased risk was found for late-onset gastrointestinal cancer, and a 23% increased risk for late-onset uterine cancer. These numbers are a wake-up call, a reminder of the intricate interplay between aging and disease. It's clear from these findings that the clock of biological aging ticks at different speeds for different individuals, and for those in whom it ticks faster, the risk of cancer looms larger and earlier. But remember, research is ongoing. These findings are part of a larger puzzle that scientists worldwide are working diligently to piece together, aiming to understand the full picture of how accelerated aging impacts our health and longevity. So, what could this mean for the future of cancer prevention and treatment? Let's explore that in our final segment. As we move forward, let's hold on to hope and curiosity, knowing that each discovery brings us one step closer to a future where we can better predict, prevent, and treat these diseases. These findings could open new avenues for cancer prevention and early detection. This statement isn't merely hopeful speculation. It's a potential game changer in the world of healthcare, particularly in the realm of cancer research. Imagine, if you will, a world where we can slow down biological aging. It sounds like science fiction, doesn't it? But our understanding of the human body is advancing at a rapid clip, and we're beginning to see that this concept might not be as far-fetched as it once seemed. If we can slow down the aging process, we might be able to reduce the risk of early-onset cancers. And it's not just about prevention. Early detection is another crucial piece of the puzzle. By tailoring screening efforts to younger individuals who show signs of accelerated aging, we could catch cancers in their earliest, most treatable stages. This could mean a significant improvement in survival rates and quality of life for those affected. But as with any scientific breakthrough, there's still a lot we don't know. That's why researchers are planning to dig deeper into this intriguing phenomenon. They're keen to uncover why younger adults are aging at a faster pace and why this is bumping up their cancer risk. This research could lead to a better understanding of the link between aging and cancer. It could help us identify risk factors more accurately and develop more effective prevention strategies. It could even change the way we approach healthcare, shifting the focus from treating illness to maintaining wellness. As we look to the future, the possibilities are exciting and vast. But one thing is clear: we're standing on the brink of a new era in healthcare, an era where we might be able to control the aging process, and in doing so, reduce our risk of cancer. As we continue to discover more about the complex relationship between aging and cancer, It's clear that staying informed and proactive about our health is more important than ever.